Hello dear grade 7 children. Today you all are here with me to learn the second lesson of science, that is static electricity. So this static electricity lesson is a very new lesson for you all. You haven't learned about static electricity before. You have learned about normal electricity. Even last year you learned about electricity. So that electricity is the electricity that you use in your day-to-day life. But the static electricity, it is a different one. So we will see what are the topics that we have to learn under this lesson. First topic, charge in an object. So under this one I am going to show you what is the meaning of charge in an object, and I am even going to show you how to charge an object. And then we are going to learn types of static electric charges. So under this topic, we are going to learn that there are two different types of static electric charges. And we are going to do some experiments to study about these different types of static electric charges. Generation of static electric charges. As the next thing, we are going to learn how to generate these static electric charges. And then we are going to learn phenomena associated with static electricity. What is the meaning of phenomena, children? Phenomena means incidents. So under this part we are going to learn what are the incidents related to this static electricity. And finally we are going to learn about capacitors. So under that we are going to learn that capacitors are small devices that can be used to store these static electric charges. So now we will start the work. Charge in an object. Now I told you before that I am going to teach you what is charge in an object, and I told you that I am going to show you how to charge an object. Right. Now before we discuss about charge in an object, you all have to do a simple activity. Now as I am explaining this one, you can start to do this. So what do you need to do this experiment, children? This small activity? You need a pen and a piece of paper. So all of you now tear the piece of paper into tiny pieces. Right, children? So after tearing it, you have to take the pen and you have to hold this pen close to those tiny pieces of paper. What can you see? I am sure you can't observe anything. Now take the same pen. You have to rub this pen on your hair thoroughly. Rub it very well. But remember, your hair should be dry. It shouldn't be oily. So if your hair is oily, you can find a piece of polythene and rub your pen with the piece of polythene. Okay, children. So after rubbing the pen, now you can hold this pen again close to these tiny pieces of paper. What can you all see, children? You must have seen that tiny pieces of paper attract the pen. So isn't this very interesting? Earlier, the pen could not attract any pieces of paper, but now what happens? It can attract these pieces of paper. What is the reason, children? This happens because of static electricity. Okay, so what actually happens here? Earlier, you just had the pen and the pieces of paper. When you hold this pen close to the pieces of paper, what happens? You can't observe anything before. But after rubbing, what happens? After rubbing, nice thing you all can observe. After rubbing, this pen can attract these pieces of paper. So it means after rubbing this pen on your hair, it can attract these tiny pieces of paper. What actually happens is, children, when you rub two different objects with each other, now you rubbed your pen on your head. Okay? So when you rub two different objects with each other, they form different types of charges called static electric charges. Okay? It means when we rub this pen on your hair, what happens? This pen gets charged. Okay, these charges formed on the pen are known as, what is the name? Static electric charges. So due to rubbing, static electric charges are formed on the pen, and therefore what happens? It can attract light things. Remember, after rubbing, even though static electric charges are formed, it won't be able to attract very heavy things, only light things like pieces of paper, pieces of styrofoam, what we call rigiform. Okay, we can attract those things by charging an object. So these type of charges formed on an object after rubbing are known as, what is the name? Static electric charges. Right. So it's very clear, due to rubbing, some type of changes take place on an object, and because of that change take place, it can attract light things. So now we are going to see this type of activity in an experiment. Okay children, we have a small experiment to do now. What is the experiment? Testing for the attraction of light things towards an object which is rubbed against some other materials. Now, do you remember how to write an experiment? You all know that there are a few steps to write down an experiment. What is the first step? Writing the title under experiment. What is the second step? Yes, that is materials. So, we have to write down what are the things we need to do this experiment. So, what do we need here? We need a glass rod. And a PVC pipe. And here we have an ebonite rod. And a polythene sheet, a piece of polythene sheet. And we need a piece of silk cloth. And we need a piece of woolen cloth. And we need tiny pieces of paper. I'll write small pieces of paper. Okay. Now, how to do this experiment, children? First of all, you can see there are 3 rods. We have a glass rod, PVC pipe and ebonite rod. So, when I am doing this experiment, instead of glass rod, I am going to use a pen tube. That is also correct. Okay. So, first of all, you have to take the 3 rods and you have to hold each rod close to these small pieces of paper and observe. Understand? And then you are going to rub the glass rod with silk cloth. And then you are going to hold it closer to the pieces of paper. Right? And then you are going to take the PVC pipe and rub it with a polythene sheet and hold it close to the pieces of paper. Right? And then you are going to take the ebonite rod and rub it with the piece of woolen cloth. Rub it nicely and you have to hold it next to these small pieces of paper. Okay children, and you have to observe what happens before rubbing and after rubbing. So now we have to write down the next step of our experiment, that is the method. So I explained you how to do this experiment. What are the steps that we have to write? We will write each. Step 1. Hold each rod close to the small pieces pieces of paper. Hold each rod close to the small pieces of paper and observe. What is the second step? You have to rub this glass rod with the silk cloth. Here I am going to use, instead of the glass rod, a pen tube rubbed with polythene sheet. Okay, and rub PVC pipe with the polythene sheet and ebonite rod with the woolen cloth. So you all know that when two things are rubbed with each other, this is known as, what is the word? Charging. So we are going to charge these rods now. Okay. Number 2. Rub the glass rod with the silk cloth and hold it close to the small pieces of paper. Number 3. Rub the ebonite rod with the woolen cloth and hold it close to the small pieces of paper. Next one. Rub the PVC pipe with the polythene sheet and hold it close to the small pieces of paper. Okay, children. Hold each rod close to the small pieces of paper and observe. Then rub the glass rod with the silk cloth and hold it close to the small pieces of paper. Rub the ebonite rod with the woolen cloth and hold it close to the small pieces of paper. And rub the PVC pipe with the polythene sheet and hold it close to the small pieces of paper. Okay, so we will do this activity now. Right, children. Now we are going to observe whether different objects can attract these light things. So as light things, we have here pieces of paper now. You all can see. And I have a PVC rod and an ebonite rod. And here I have a pen tube and a piece of polythene and a piece of woolen cloth. So first of all, these are the 3 rods I have. I am going to hold each rod close to this paper, so you all can see they can't attract these pieces of paper, children. Okay. So we are going to check whether after rubbing these tubes with this piece of woolen cloth and this polythene sheet, if something happens to these rods, we will see now. I am going to take the PVC tube first and I am going to nicely rub this PVC tube with the polythene sheet. So this is known as charging, children. So when we rub two substances with each other, what happens? They get charged. These charges are known as static electric charges. Now see what happens. Can you all see? It can nicely attract these tiny pieces of paper. Earlier, could it attract any tiny piece of paper here? No. That is because this PVC tube was not charged. Now when I rub it with this polythene sheet, it gets charged. Okay? Right. We will check it with the others. I'm going to take this ebonite rod and I'm going to charge it with this piece of woolen cloth. You all can see how nicely they attract towards this ebonite rod. So we will check it with this pen tube. I'm going to take the pen tube and I'm going to again rub it with this polythene sheet. See, it's very clear. Even this pen tube can attract these tiny pieces of paper after rubbing it with this polythene sheet. So what does it happen, children? When I rub these three different rods, it collects charges. So because of the collection of charges, they can attract these light things like tiny pieces of paper or styrofoam balls likewise. So these type of charges that collect on these objects by rubbing are known as static electric charges. Right, children? So did you observe what happens? So I hope it's very clear now. You all observed what happened. So you saw that before rubbing, what happened? Before rubbing each rod, they could not attract any piece of paper. But after rubbing, what happened, children? After rubbing, they could attract the pieces of paper. So we will write it under observations. So what is the instance? First instance, before rubbing. Before rubbing. So what are the objects we used? We used three rods. What are they? Glass rod. Instead of the glass rod, I showed you with the pen tube. So I will write it here as well. And then ebonite rod. And the PVC pipe. Okay. So what was the observation? When held close to the pieces of paper, what happened? The pieces of paper did not attract to these rods. Okay. We'll write. So because it's one observation, I'll write only one for all three instances. Right. Pieces of paper did not attract to the rods. Okay. So what is the second instance? After rubbing. Now before rubbing, only with these objects, we observed what happens with the pieces of paper, and after rubbing. After rubbing. So what are the objects we use? The same three types of rods, but here this time we rub them with different other objects, right? So the first one, what you have to do is glass rod should be rubbed with piece of cloth. Instead I rubbed a pen tube with a piece of polythene. So in the experiment given in the textbook, you have to use glass rod. Therefore, I will write it here. So glass rod rubbed with silk cloth. And second one, ebonite rod rubbed with woolen cloth. Ebonite rod rubbed with woolen cloth. Okay, the third one, PVC pipe rubbed with PVC pipe rubbed with the polythene sheet. Okay, glass rod rubbed with silk cloth, ebonite rod rubbed with woolen cloth, and PVC pipe rubbed with polythene sheet. So what could you observe after rubbing? What was the observation? Yes, pieces of paper here attracted to the rods. We will write. Pieces of paper attracted to the rods. Understand, children? So earlier, without rubbing, the pieces of paper did not attract to the rods. But after rubbing, what happened? Pieces of paper attracted to the rods. So what is the conclusion? What do we have to write under conclusion, children? Under conclusion, we have to write down, after doing an experiment, what is the decision that we can come up with. So what is the conclusion? Earlier, the different types of rods, they could not attract any piece of paper. But after rubbing, what happened? They could attract the pieces of paper. So it means during rubbing, when we rub something, what happens? Some kind of change takes place. Still, we can't say this happens because of static electric charges. I explained you this happened because of static electric charges formed. But actually, by this experiment, what we can decide is, during rubbing, some type of changes take place in the rods. Okay, so we will write down. Rubbing an object can make a certain change to it. Certain change to it. So this is the conclusion, but within brackets I am going to write the reason as well. So due to rubbing, objects get charged. Objects get charged. Because of the charges present, because of the charges present, because of the charges present, they can attract can attract light things. Right. Okay, children. Rubbing an object can make a certain change to it. What actually happens is, due to rubbing, objects get charged. This is why when we rub two objects with each other, we call it charging under this lesson, right? So because of the charges present, they can attract light things. Okay, children. So I hope this experiment is very clear now. So here we have a fact. The scientist William Gilbert was the first to reveal that light things are attracted to rubbed objects. So now we all know that when an object is rubbed, it gets charged and therefore it can attract different light things. So this incident was first observed by the scientist called William Gilbert. So how did they observe this? Look at this one. So under extra knowledge, this part is given. Scientist William Gilbert observed that when a piece of solid amber we used to make jewelry, right? Piece of solid amber is rubbed with a silk cloth, light objects like tiny pieces of paper and feathers are attracted to it. So he observed this incident and then he did experiments on that, right? Gilbert said that electric charges are generated. Electric charges are generated on the surface of objects when they are rubbed. Okay? So light objects are attracted to them. So he did many experiments even after that. Therefore, when some objects are rubbed, what are generated, children? Electric charges are generated. Electric charges. Electric charges are generated on them. Understand? So, electric charges generated on the surface of objects by rubbing, they are known as static electric charges. Okay, children? Electric charges generated on the surface of objects by rubbing are called, what is the name? Static electric charges. Static electric charges. Right. So what happens? When some objects are rubbed, electric charges are generated on them, and electric charges generated on the surface of objects by rubbing, they are known as static electric charges. So now you all know that what are static electric charges. So under this lesson we are learning about static electricity. It's a different type of electricity than the electricity that we use in our day-to-day lives. So here what happens? By rubbing objects, static electric charges are generated. Okay, we have another experiment to identify these different types of charges. So by now we all know that there are types of electric charges called static electric charges. Static electric charges are generated due to rubbing of objects. Okay, but you don't know what are the different types of static electric charges. The only fact you know is there are static electric charges. They are generated by rubbing an object. So we are going to do this experiment to identify what are the types of charges. Okay, so activity, studying about the static electric charges. So what are the materials we need? We need 2 glass rods and 2 ebonite rods and a piece of silk cloth, a piece of woolen cloth and some pieces of thread and stands. Okay, we need 2 stands. We will write down this. 2 glass rods and 2 ebonite rods, 2 ebonite rods, and we need a piece of piece of silk cloth. And a piece of woolen cloth. Woolen cloth. And we need a few pieces of thread. And 2 stands. Okay, children. So what do we need here? 2 glass rods, 2 ebonite rods, a piece of silk cloth, a piece of woolen cloth, and a few pieces of thread and 2 stands. So we will see how to do this activity. So if you have to explain the experiment a lot, you can even use a picture. That's easy for you. So here we have the picture. So what do we have to do? So first of all, you have to take 1 ebonite rod and you have to nicely charge it with a piece of woolen cloth. It means you have to rub the ebonite rod with the piece of woolen cloth. And then you have to hang it on the stand. Okay? And then you have to take a glass rod and you have to rub the glass rod with a piece of silk cloth and you have to hang that also on the stand. Now what you have to do? You have to take the second glass rod. I told you you have to take 2 glass rods and 2 ebonite rods. Okay? So you have to take the second glass rod, then you have to charge that as well. What is charging again? You have to rub the glass rod with the piece of silk cloth. Okay? So after charging it, you have to take this glass rod close to this ebonite rod and observe. Again you have to take this glass rod, the charged one, close to this other glass rod which is hanging, and then observe. Understand, children? Then again you have to take the other ebonite rod. Now already 1 ebonite rod is hanging like this. Okay? You have to take the other ebonite rod and you have to rub it nicely with the woolen cloth. Okay? So after rubbing it with the woolen cloth, you have to take the second ebonite rod close to this ebonite rod that is hanging. Understand? And then again the same ebonite rod you have to bring close to this glass rod which is hanging and observe what happens. Step 1. Hang the ebonite rod rub with the woolen cloth and the glass rod rubbed with the silk cloth. On stands. Okay. Second one. Rub the other ebonite rod with the woolen cloth, and bring it close to each of the hanging rods. Third one. rub the glass rod with the silk cloth and bring it close to each of the hanging rods. Okay. Hang the ebonite rod rubbed with the woolen cloth and the grass rod rubbed with the silk cloth on stands. And then rub the other ebonite rod with the woolen cloth and bring it close to each of the hanging rods. Right? And rub the other glass rod with the silk cloth and bring it close to each of the hanging rods. Okay, so it's very clear what you have to do now. When I do this activity, instead of the glass rod, I'll be using a pen tube, but you will see the same result, okay? So now we will go see this activity. Right, children? Now we know that after rubbing objects, they can attract light things because of generation of static electric charges. But we do this experiment in order to find out what are the different types of static electric charges generated. You know that static electric charges generate, but we don't know what type of static electric charges are there. Okay, so here I have this ebonite rod, one is hanging, I have another free ebonite rod here. And here I have a plastic tube hanging and another free plastic tube as well. So I'm going to take this plastic tube close to this other plastic tube. Nothing happens. Even when I hold it closer to this ebonite rod, nothing happens. Right? So if I hold this other ebonite rod next to this hanging ebonite rod, nothing happens. If I hold it next to this plastic tube, again, no change. Now what I am going to do is, I am going to take this woolen cloth and I am going to rub one ebonite rod, what is hanging here, really well. And after that, I am going to take this polythene sheet and going to rub this pen tube really well. And again, I am going to take the other ebonite rod and rub like this with the woolen cloth. So the ebonite rods are rubbed with the woolen cloth. Okay, plastic tube is rubbed with the polythene sheet. I will take this ebonite rod and rub it again. Right. Now I am going to hold this ebonite rod rubbed with the woolen cloth next to this ebonite rod rubbed with the woolen cloth. So you can see this ebonite rod moves away from this one. See, when I hold from this side, it moves to the other side. Right? See what happens, children? You can see they repel each other. They move away from each other. Okay, children? So both the ebonite rods are rubbed with this woolen cloth. So what happens when I try to keep them together? They move away from each other. A repulsion is there. What will happen? Did you see? When I hold this ebonite rod closer to this plastic tube, what happens? They attract. They come together. So when I keep these two ebonite rods rubbed with the woolen cloth, they repel each other or they move away from each other. But when we keep this ebonite rod rubbed with the woolen cloth and the pen tube rubbed with the polythene sheet, they attract. Okay? So I will do the same experiment in a different way. This time I am going to rub the ebonite rod with woolen cloth again. So you will know this is known as charging. That is because when you rub these objects with different other substances, they get charged. Therefore, two different objects are rubbed with each other is known as charging because they collect static electric charges. So what are static electric charges? Electric charges generated on objects due to rubbing. Right. Again, this hanging pen tube I am going to rub with the polythene sheet. And I am going to take the other pen tube and that also I am going to rub with the polythene sheet. Right. Now observe carefully. I am going to hold this pen tube next to the other pen tube. So you can see this plastic tube move away from the other one. So when I hold it from this side, what happens? They still repel. What about this one? So you all can see when I hold this plastic tube rubbed with the polythene sheet next to this ebonite rod rubbed with the woolen cloth, what happens, children? They attract. See, when I hold from this side also the same thing happens. Okay, children? Right. Understand? So what actually happened here? Now you all know that these two pen tubes I rub with the polythene sheet and these two ebonite rods I rub with the woolen cloth. So when I rub these two pen tubes with the polythene sheet, these pen tubes gain one type of electric charges. So when I rub these two pen tubes with the polythene sheet, they collect the same charges, and when I rub these two ebonite rods with the woolen cloth, they collect the opposite charges. So actually these charges are positive and negative charges. Understand? So when we rub this ebonite rod with the woolen cloth, ebonite rod gets negatively charged. Okay? And when I rub this plastic tube or pen tube with the polythene sheet, it collects positive charges. So what happens? When we rub these two pen tubes with the same polythene sheet, they will collect the same type of charges. So what happens when I kept these two pen tubes together? They repel. So it's sure that because we use the same polythene sheet to charge both these pen tubes, they collect the same type of charges. But when we try to keep them together, they repel each other. So we can come to a conclusion that like charges repel or equal charges repel or move away from each other. Understand, children? So when you consider about these two ebonite rods, what happens? The same thing. When I rub these two ebonite rods with this woolen cloth, they also collect the same type of charges. So that is why earlier when I tried to keep these two ebonite rods together, what happened, children? They repelled. That is because like charges repel each other. Understand? But what happened? When I tried to keep the ebonite rod closer to the pen tube or the pen tube closer to the other hanging ebonite rod, what happened? Both instances, they attracted towards each other. It means they collect opposite charges. When we consider this pen tube and the ebonite rod, the charges present on these two tubes are opposite to each other. Okay? So there we can come into a conclusion that unlike charges or opposite charges attract. Okay, children? So it's very clear there are two different types of charges in static electricity, right? So positive and negative charges, opposite charges or unlike charges attract, and like charges or same charges, they repel. Okay, children? So did you observe what happened when we were doing this experiment? I hope it's very clear now. So We will write the observations in a table like this. We have one column, the hanging rod, the rod brought towards, and observations. So what are the hanging rods we had? We used a pen tube instead of the glass rod. Therefore, here I am going to write the pen tube. But remember, the same observation will be there when you use the glass rod, okay? Pen tube. Even here, I will write the pen tube. These two instances also the same. Pen tube. And the pen tube. Okay. So, the first observation is given. This was very clear. What happened when we brought the free pen tube towards the hanging pen tube? What happened, children? They repelled each other. Okay. So, what happened when we brought this free pen tube towards the hanging ebonite rod? I hope you remember. They came close to each other and they touched. It means it's an attraction. They attracted. Okay. So, we will write attracted. Okay. So, then we use the next hanging tube as the pen tube. What happened when we brought this free ebonite rod towards the hanging pen tube, children? Again, there was an attraction. Okay. So, attracted. Understand? Ebonite and ebonite rod, both the rods we used were ebonite rods. It means hanging one and the free one. So what happened then, children? So when we brought one ebonite rod towards another ebonite rod, they repelled again. Repulsion. Okay? Repelled. Right, children? So it's very clear. Same type of rods, what happened? They repelled each other. Look at this table, pen tube and pen tube. You can use glass as well. Pen tube and pen tube repelled, and here again ebonite rod and ebonite rod repelled. But what happened when we brought opposite rods with each other? They attracted. Okay, so now you all know that when we rub two different types of objects, what happens, children? They get charged. They collect static electric charges on them. So after doing this experiment, it's very clear. So after rubbing, they all collect static electric charges, but there are different types of static electric charges. Okay. So after doing the experiment, what is the conclusion that we can come up with? There are attractions and repulsions between static electric charges. So we will write that down. There are attractions and repulsions. Between static electric charges. There are attractions and repulsions between static electric charges. So far we learned that there are something called static electric charges or static electricity. How does the static electricity generated? That is by rubbing an object. And now we know that there are different types of static electric charges. So after doing this experiment, we can understand that there are attractions and repulsions between static electric charges. So here we have the same idea expressed by a diagram. Attractions and repulsions between charged rods. Okay, so here we have glass rod rubbed with silk and another glass rod rubbed with silk. I will name it. This is also a glass rod rubbed with silk. Okay. So what happens when one glass rod rubbed with silk brought towards the other glass rod rubbed with silk? They repel. They move away from each other. But at the same time, what happens when glass rod rubbed with silk is brought towards the ebonite rod rubbed with wool, children? What happens? They attract. They come close to each other. It means they attract. So what can you decide after doing this activity, children? Sometimes, now both the instances you all know that static electric charges are formed. Okay, when you rub something, when you rub an object, static electric charges are formed. So even after doing that previous experiment, it's very clear. Sometimes these static electric charges, they repel each other and sometimes they attract each other. What is the reason, children? We can assume that there might be two different types of charges. Okay, so in another way, there might be two different types of charges are formed by rubbing. Okay, so the reason for the attraction and the repulsion between charged rods is the existence of two types of static electric charges. Okay, existence of two types of static electric charges. That might be the reason they behave in a different way, like two different ways. Okay, so what can you assume after doing this experiment? What else we can say after doing this experiment? Look at this first picture, right? One glass rod and another glass rod present. Okay, we use two glass rods. Now glass and glass means here the same material. And at the same time, we use the same silk cloth to rub these two glass rods. So we can assume that they get charged in the same way. It means the same type of charges present on both the glass rods. So what happened? If we assume that the same type of charges present on each glass rod, what can we say that? So when same type of charges present, they repel. Understand? So we can say same charges, what happens? Repel. Understand? Here what happens? We have one glass rod rubbed with silk and ebonite rod rubbed with wool. There are two different types of materials, two different rods and two different other substances used to charge these two rods. So here we can assume that the types of static electric charges present on these rods are different. At the same time, here what happens? An attraction. You could observe an attraction between two rods. So we can come to another conclusion. When different types of charges present on objects or here the rods, they attract. Okay. Same charges repel, different charges what happens? Attract. Okay. What happens here? The reason for the attraction and the repulsion between charged rods is the existence of two types of static electric charges. Okay. So when the same type of charges present, they repel each other, and when different types of charges present, they attract. Understand? So what are these two different types of charges, children? There are two types of charges. Remember, there are two types of static electric charges called positive static electric charges and negative static electric charges. So if you look at this picture very clearly, it's already mentioned here. Can you see plus marks? These positive charges are mentioned on this one glass rod. You can see it, right? Even on this glass rod, these plus marks are mentioned. It means positive charges present on both glass rods. Understand? Look at this one. Here on the glass rod, positive charges present, but look at the ebonite rod rubbed with wool. Negative charges present. Okay, so you'll know that positive charges present here. That is why a repulsion present. Okay, that's why they repel each other. The same time here positive and negative charges present. Therefore, you can see an attraction. So our assumption is correct, right? We assume that there are two different types of charges and same charges repel and different charges attract. Okay, so after doing this activity, it's clear two different types of charges present, and now we know what are the two types of static electric charges, children. Positive and negative charges. We will write. Number 1, positive static electric charges and negative static electric charges. Understand? So there are two types of charges, positive static electric charges and negative static electric charges. Objects with what type of charges repel each other? Look at this picture again. Positive and positive. It means equal or the same charges. Okay, let's say that if there were two ebonite rods together, they will also repel. Because when we take two ebonite rods rubbed with wool, they both have the same type of charges that are negative charges. So positive repel, negative also repel. Okay, and positive and negative, it means different charges, they attract. Okay, so what repels each other? Positive charges and negative charges. These type of same charges, so equal charges, are known as, we give a special name, like charges. Okay, objects with like charges. Objects with like charges repel each other. Okay, and the next one, objects with opposite charges, they attract. So for the opposite charges, we give another name, unlike charges. Objects with unlike charges attract each other. Okay, so there are two types of charges, positive and negative static electric charges. Objects with like charges repel each other. Okay, it means if there were two rods, both of them are positively charged or both of them are negatively charged, they will repel each other. Okay, objects with unlike charges attract each other. If the two rods are positively and negatively charged, they will definitely attract each other. Understand, children? We have a small activity to do. Read this question. A PVC rod rubbed with a polythene sheet is hung with a thread. When a glass rod rubbed with silk is brought towards the PVC rod, it is attracted. What is the type of static electric charge on PVC rod? Okay, so if you get this type of question, the first thing you can do to understand the question better is drawing a small diagram. Okay, we will do that. So what is explained here? A PVC rod rubbed with the polythene sheet is hung. The hanging rod is the PVC rod. I will draw a string like this and it's hanging like this. Okay, it says a PVC rod rubbed with the polythene sheet. This is the PVC rod. Okay. When a glass rod rubbed with silk is brought towards the PVC rod. Here we have a glass rod rubbed with silk. glass rod. Okay. In the previous part, I showed you what happens when a glass rod is rubbed with silk. What type of charges it collects. Look at this one. Glass rod rubbed with silk. As a fact, you have to memorize. Glass rod rubbed with silk collects positive charges. Okay. So, what happens here? We have a glass rod rubbed with silk. What type of charges present on this glass rod then? Positive charges. So we will draw with a different color. These are positive charges. Okay. So here what happens when a glass rod rubbed with silk is brought towards the PVC rod? It is attracted. They attract. They go close to each other. An attraction could be seen. What is the type of static electric charge on PVC rod? So what did we learn before, children? As a fact, we learned like charges repel each other. Unlike charges attract each other. So in order to show an attraction, unlike charges should present. Okay? These two are attracted to each other means both of them are charged in different ways, in opposite ways. So one rod has positive charges because we already know that after studying the other part. Okay, glass rod rubbed with silk always gets positively charged. So in order to attract this glass rod and PVC rod, what type of charges should present on PVC rod, children? Definitely negative charges. Therefore, PVC rod has negative charges. So what is the theory we used here in order to come to a conclusion like this? Like charges repel each other. Repel each other. What is the other one? Unlike charges, attract each other. Understand, children? So this question says PVC rod rubbed with a polythene sheet is hung with a thread. When a glass rod rubbed with silk is brought towards the PVC rod, it is attracted. So in order to show an attraction, what happens? They both should contain unlike charges or opposite charges. So by looking at this glass rod, now we all know that when glass is rubbed with silk, it gets positively charged. Okay, so this PVC rod must contain negative charges in order to attract each other. Therefore, what is the answer? What is the type of static electric charges on PVC rod? The PVC rod has negative charges. PVC rod has negative charges. Okay, glass rod has positive charges. Therefore, PVC rod must have negative charges. Understand, children? Okay. For extra knowledge part, we will go through this. There are various equipment to identify static electric charges. One of them is the gold leaf electroscope. This is the picture of the gold leaf electroscope. When a charged object is brought towards the metal plate of this electroscope, now here this is the metal plate. Metal plate. Why do we call this gold leaf electroscope? Here you can see a gold leaf is present here. Very thin gold leaf. Okay. So what happens? When a charged object is brought towards the metal plate of this electroscope, if you bring a charged object next to this one, this plate, what will happen? The gold leaf deflects, right? This gold leaf deflects. It shows a movement. Okay, so thereby this instrument is very important to indicate that there are static electric charges present. Understand, children? By now you all know that there are static electric charges present, and there are two different types of static electric charges. What are they? Positive and negative charges. To understand these positive and negative charges better, we can do this simple activity. So what is the activity? Testing for static electric charges. Now remember, this activity you all can do at home. Okay, it's very easy one. Okay, children. So what are the things we need or materials? We need 2 drinking straws. Okay, 2 drinking straws. 2 drinking straws, plastic straws, and we need a drawing pin. We need a drawing pin. And we need a glass. And we need a polythene sheet. A polythene sheet or a piece of polythene. Right? So the drinking straws should be clean and dry. Understand, children? So we need 2 drinking straws, a drawing pin, a glass, and a polythene sheet. So how to do this activity? I will show you. How to do this? First of all, you have to take 1 drinking straw and you have to charge it with the polythene sheet. So what is charging again, children? Charging means rubbing with another object. So you have to charge or you have to rub 1 drinking straw with the polythene sheet. And then you have to balance it on the upturned glass using a drawing pin. Okay, so this is the drinking straw and this is the drawing pin. Drawing pin and upturned glass. Okay, and then what you have to do is you have to take the other drinking straw that is also should be charged with the same polythene sheet. Okay, so take the other drinking straw and you have to charge it again with the polythene sheet which we used to charge the first drinking straw. Okay, so after charging that one, you have to keep it close to this drinking straw, the first one. Understand? So you have to keep the second drinking straw, the charged one, near the first charged drinking straw and observe what happens. And then you have to take the polythene sheet you used to charge the drinking straw and you have to keep that polythene sheet close to this drinking straw which is on the glass. Understand? And the third one you have to do is you have to keep a finger closer to the drinking straw. So what do you have to do again? First you have to charge 1 drinking straw and then you have to balance it on the glass and you have to take the other drinking straw and you have to charge that one as well. Then that charged drinking straw you have to bring close to the first drinking straw and observe what happens. Okay, and then you have to take the polythene sheet you used to charge this drinking straw and you have to keep it closer to this drinking straw. And finally you have to keep 1 finger near the charged drinking straw and observe what happens. Understand? So we will write down the method now. So what is the first thing to do? Charge a drinking straw with the polythene sheet, and balance it on the glass using the drawing pin. Right. Number 2. Charge the other drinking straw with the same polythene sheet. And keep it close to the first straw. Right. And what is the next step, children? Now keep the polythene sheet used to charge the straws near the first drinking straw, which means a drinking straw on the glass. And finally, keep a finger close to the first drinking straw. Okay, is it clear, children? First step, charge a drinking straw with the polythene sheet and balance it on the glass using the drawing pin. Right? Charge the other drinking straw with the same polythene sheet and keep it close to the first straw. Now keep the polythene sheet used to charge the straws near the first drinking straw, which is on the glass. Right? And keep a finger close to the first drinking straw and observe what happens. Now we will do this activity. Right, children, I have the setup here now. As I explained you have to balance one straw, drinking straw, on a glass using a drawing pin. Okay? So, and here I have another drinking straw. First of all, I am going to take this polythene sheet and I am going to charge this straw. Rub these two things with each other. So you all know that what happens. Now we know about positive and negative charges. So when we rub two different things with each other, they will get charged. Now I am going to take the other drinking straw and I am going to charge that drinking straw as well. So both the drinking straws, they are equal and I charge both the drinking straws with the same polythene sheet. And now I am going to hold this closed. See what happens, children? This drinking straw moves away from this drinking straw. It means a repulsion. So why does this happen? Repulsion happens, that is because of collection of like charges, the same charges. Right. Now I am going to bring this polythene sheet closer to this one. You all can see that they attract. When we rub these two objects with each other, they both get charged. So one object gets positively charged, the other object gets negatively charged. So positive and negatively charges are unlike charges, so opposite charges. So when I keep it like that, straw has one type of charges and the polythene sheet has the other type of charges. So what happens? As I explained you before, unlike charges attract. That is why it shows an attraction. So I am going to keep my finger closer to this straw. So what happens? No attraction, no repulsion. What is the reason? That is because my finger is not charged. So this type of objects, the charged objects, they show attractions or repulsions only with another charged object. Okay? So as my finger is not charged, there's no attraction, no repulsion. So it's very clear that there are two different types of charges, and like charges repel and unlike charges attract. Right, children? So did you observe what happened? So I hope it's very clear, and you must have done the experiment at home now. So it's very clear that there are different types of observations we could see. So what could we see, children? When you keep one charged drinking straw close to the first drinking straw, what happened? They repelled, they moved away from each other. Right, children? So what happened when you take the polythene sheet you used to charge the drinking straw, and when you kept it closer to the drinking straw, what happened, children? They attracted. Okay? But what happens when you kept a finger close to the drinking straw? Could you see anything? There was no observation. Okay, children? So we will write down the observations now. Now I am going to use a table to write the observations. It's very clear then. Okay, so the first column I am going to write things brought close to the first drinking straw. First drinking straw was on the glass. On the glass, that was on the glass. Right? Things brought close to the first drinking straw. There were three things. And observation. Okay, so there were three things. What was the first one? We will write the other drinking straw. I will write with a different color. The other drinking straw. Okay, what happened? What was the observation? When one drinking straw brought towards the other drinking straw, what happened, children? They repelled. Repelled. Okay? The other drinking straw repelled. The second one, the polythene sheet. What happened, children? When we brought the polythene sheet close to the drinking straw, what happened? Attracted, right? Attracted. Third one, finger. What happened with the finger? Could you see any attraction or repulsion, children? There was no any attraction, no repulsion. Okay? No attraction or repulsion. Okay. So what is the conclusion now? Why did this happen, children? You all know that when we use two drinking straws, it means the same material. And both instances, we use the same polythene sheet to charge them. So what happens? Both drinking straws, when we charge them with the polythene sheet, they collect the same type of static electric charges, which means like charges. So you all know that when we keep them close to each other, it means like charges present. What will happen with the like charges or equal charges? They will repel. Like charges repel. When you use the polythene sheet, what happens, children? Now remember, when you use this polythene sheet, when you rub the polythene sheet with the drinking straw will get one type of charge and the polythene sheet will get the opposite charge. Okay, so I'm going to explain this later very clearly. Okay, so the polythene sheet gets the opposite charge than that of the drinking straw. So it means we learn that unlike charges attract. That is the reason for the attraction. But what happens with the finger? Finger we did not charge. Okay, these attractions and repulsions will appear only with the charged objects. If some object is not charged, we can't expect any repulsion or attraction. That is why here under observation, we can't see any attraction or repulsion under finger. Okay, so what is the conclusion? It's very clear that there are two different types of static electric charges. Like charges, what happens with the like charges? Equal charges, they repel, and unlike charges, so opposite charges, they attract. Okay, we will write. There are two types of static electric charges. And like charges repel each other and unlike charges, it means opposite charges, attract each other. Right, children? There are two types of static electric charges. Like charges repel each other, unlike charges attract each other. I hope this part is very clear now. Okay, our next topic is generation of static electric charges. Now we all know that static electric charges are formed by rubbing an object, and there are two different types of static electric charges are formed as positive and negative charges. Now we are going to discuss that how does this happen, children? You all know that by now there are two types of charges, but still we don't know what actually happens here. Now I am going to show you what happens here. We will see the amounts of and particles are equally distributed on an object before it is rubbed. What actually happens? What happens before rubbing an object? Now look at this very carefully, children. I am going to explain this to you. Now you all have to look at this very carefully, then only you can understand. Okay. So for now I will write the amounts of positive and negative particles. Right? The amounts of positive and negative particles are equally distributed. This is very important. Equally distributed on an object before it is rubbed. Okay, therefore, the object does not show any net charge. If equal amounts of positive and negative particles are present, we can't call an object positively charged or negatively charged. Okay, it means it is neutral, no specific charge present. Okay, therefore the object does not show any net charge. Any net charge. Right. So what actually happens, children? Remember, look at these two pictures. Let's say that there are two objects like this. They are not rubbed yet. Okay. So before rubbing, what happens? It says the amount of positive and negative particles are equally distributed. So how can we show that one? Right. Let's say this object, it has certain number of positive particles and it has equal number of negative particles. For example, if this has 5 positive particles, at the same time it has 5 negative particles as well. Let's say even this rod has 5 positive particles. So before rubbing, it will have 5 negative particles too. It means positive and negative are equal. Okay, so this is before rubbing. Positive and negative particles are equal, which means the number of positive and negative particles are equal and they are equally distributed throughout the object. Understand? So, for example, here on this object, we have 5 positive particles, 5 negative particles. So, if this object has 5 positive particles and 5 negative particles, which means the equal amounts, can we call this object is positively charged? No. Right? But at the same time, can we call this object is negatively charged? It's also not. It means what is the total charge? Total charge is 0. That is because equal number of positive and negative particles are present. Understand? So same goes with the rod, the other object. Okay? The number of positive and negative particles present on the object before rubbing, what happens? They are equal. Okay? Because they are equal number of positive and negative particles are present, we can't call this is positively charged or negatively charged. Okay? Therefore, this is neutral, no charge present at the moment. But what happens during rubbing? When we rub two objects with each other, what happens? That is the most interesting part here. Remember, what happens during rubbing? Remember, when we rub two objects with each other, now earlier positive and negative particles present on one object and another certain amount of equal number of positive and negative particles present on the other object as well. So when two objects are rubbed with each other, remember this carefully, only one object removes its negative particles, which means negative particles go from one object to the other object. Certain amount of negative particles move from one object to the other object. Now let's say this object is the object that removes the negative particles. It means after removing, they will go deposit on the surface of the other object. So negative particles are removed from one object to the other object. But remember, there's no movement of the positive particles. Positive particles will remain the same. Only the negative particles will move from one object to the other object. So, only from one object, negative particles move to the other object. Okay, children? So, what happens after removing this number of negative particles to the other object? Now, let's say, earlier on this object, there were 5 positive particles and 5 negative particles. Right? Even on this object, there were 5 positive particles and 5 negative particles. I will write it as a number. It's very clear then. Before rubbing, what happens? Positive particles here. Positive particles, 5. Negative particles, 5 on the first object. Second object also, positive particles 5, negative particles 5, equal. So let's assume that this rod-like object removes its negative particles. So what will happen after rubbing? Now earlier it was 5 positive and 5 negative particles. Now this first object got some extra negative particles from the other object. Therefore, this will have more negative particles than positive particles. This will have more negative particles. After rubbing. After rubbing. Okay. What about this one? Now earlier there was 5 positive particles and 5 negative particles. So some of these negative particles will go to the other objects. What will happen to the total number of particles? Now that will be more positive particles present than the negative particles. Okay, earlier equal number of positive and negative particles were present. Now some of the negative particles go to the other one. Therefore, this will have less number of negative particles but more positive particles. So this has more negative particles. The other object has more positive particles. This happens after charging, after rubbing, right? So the first object gets more negative particles because the other object removed the negative particles. Okay? The second object has more positive particles because that is the object that removed the negative particles which present before. Okay. So it's very clear. After rubbing, one object has more negative particles, the other object has more positive particles. So the object with more negative particles is known as the negatively charged object. Negatively charged object. Right? And what about the other? Obviously, the object with more positive particles after rubbing is known as the positively charged object. Okay? Positively charged. Understand? So during rubbing, negative particles move from one object to the other object. Positive charges will be the same. Only the negative charges move from one to the other. And there's a special name given to these negative charges. They are known as electrons. Right? You will learn about the electrons later in upper grades. So these negative particles are known as electrons. Understand, children? We will write down this one. Now already we know the amounts of positive and negative particles are equally distributed on an object before it is rubbed. And therefore, the object does not show any net charge. Look at this. 5 positive, 5 negative on the first object. We can't call it positively charged or negatively charged. And the second one, again 5 positive, 5 negative. So we can't call it positively or negatively charged because they are equal. Right? Therefore, the object does not show any net charge. When the objects are rubbed against each other, now see, electrons remove from one object and transfer to the other object. Which particles are moved from one object to the other object? Negatively charged particles. And the name given to this negatively charged particle is electrons. Okay? So when objects are rubbed against each other, negatively charged particles. Negatively charged particles. or electrons removed from one object and transferred to the other object. So if we take this example, negative charges move from this down object to the other object. Okay? The object from which negatively charged particles are removed. The object from which negative charged particles are removed is charged. Now this is the object that removed the negative charges. Therefore, it has more positive particles or positive charges because it already removed some negative particles. Okay? Therefore, the object from which negative charge particles are removed is charged which way? Positively. Okay? Is charged positively. And the object that gained negative particles. Now, this is the one that gained negative particles, got new negative particles from the other object. Okay? And the object that gained negatively charged particles is charged. Now, it has more negative particles. Therefore, it is negatively charged. Charged particles is charged negatively. Okay. The object from which negatively charged particles are removed is charged positively, and the object that gained negatively charged particles is charged negatively. Understand, children? So we will go from the beginning. The amounts of positive and negative particles are equally distributed on an object before it is rubbed, and therefore the object does not show any charge. When the objects are rubbed against each other, negatively charged particles or electrons, special name, remove from one object and transfer to the other object. And the object from which negatively charged particles are removed is charged positively, and the object that gained negatively charged particles is charged negatively. Understand? Now I am going to show the same story with a special activity. Okay, children, here we have a very good activity to show you what we explained before. Okay, so look at, there are two objects here, a sweater and a balloon. Okay, so if you look at this balloon, there are 4 positive charges and 4 negative charges. It means charges are equal. So what is the net charge of this balloon, children? Can you say this is positively charged? You cannot, and it is not even negatively charged. That is because equal number of positive and negative charges are present. Therefore, at the moment, this object or the balloon is neutral. Okay? So look at the sweater. You all can see positive charges are equal to the number of negative charges. The equal amount of positive and negative charges are present, just like the balloon. So the sweater is also neutral at the moment. We can't say that this is positively charged or negatively charged. That is because equal number of positive and negative charges are present. Understand? So see what happens when I take this balloon to this sweater. You can see negative charges go to the balloon. Now balloon has more negative charges. Can you see? The balloon gains negative charges. So I will take it here. You can see clearly the balloon has more negative charges than positive charges. Look at the sweater. Sweater has more positive charges than the negative charges. So which means the balloon is negatively charged. That is because this balloon has more negative charges. Okay? And the sweater has more positive charges. Therefore, we can say that the sweater is positively charged. So what will happen? We have two objects after rubbing. We have two objects. One is negatively charged and one is positively charged. If we keep them close to each other, what would happen? You all know that unlike charges attract. So I will release this balloon now. I kept it closer to the sweater and I am going to release it. See what happens? You all can see it attracts towards the sweater. Okay, so I will take it back here. if I take the normal neutral balloon, this is the first situation. Equal number of positive and negative charges present on the sweater and equal number of positive and negative charges present on the balloon. So if I take this balloon close to this sweater, what will happen? You can't see any attraction like before. Okay, that is because this balloon is neutral and at the same time the sweater is also neutral. But what happens when we rub two objects with each other? One object gets negatively charged. That is because negative charges, so electrons, they move from one object to the other object. What will happen to the positive charges? Will they move from one object to the other object? They do not. Only the negative charges will move. So I will move it here and I start rubbing. What can you see? Negative charges move from the sweater to the balloon. But nothing happens to the positive charges, children. They will remain the same. So the balloon collects more and more negative charges upon rubbing. So what happens now? The balloon is negatively charged and the sweater is positively charged. That is why two objects with opposite charges, they will attract. Understand, children? So I hope this activity is very clear. So here we have the same story again, children. Now we discussed what happens when we rub two objects with each other. So here we have the summary of that story. Okay. So we have three incidents: before rubbing, while rubbing and after rubbing. So what happens before rubbing? What can you tell about the number of charges? So on the cloth and glass rod, now equally distributed positive and negative charges present. So the same number of or the same amount of positive and negative charges present on cloth. And even on the glass rod, when you consider the total number of positive and negative charges, they are same. So we will write down this one. In each object, number of positive charges are equal to the number of negative charges. Therefore, no any net charge. Which means neutral. So while rubbing, what happens, children? Negatively charged particles. What is the name of these negatively charged particles? Electrons, right? So while rubbing, negatively charged particles or electrons, they remove from one object to the other object. Okay, and they will remain on the surface of the other object. We will write that. While rubbing, negatively charged particles remove from one object to the other object. Right? Negatively charged particles removed from one object to the other object. And after rubbing, what happens? Because of removal of these negatively charged particles from one object to the other object, now one object has more negative particles and the other object has more positive particles. The one with more positive particles is known as the positively charged object, and the one with more negative particles is known as the negatively charged object. Okay, we will write. One object has more positive particles. Positively charged particles. Therefore, it is charged positively. The other object has more negative particles, more negatively charged particles. Therefore, it is charged. It is charged negatively. Understand, children? So before rubbing, now here we have the glass rod and the cloth. In each object, number of positive charges are equal to the number of negative charges. Therefore, no any net charge, which means both the objects are neutral. Okay. So while rubbing, what happens? Negative charges, so electrons, they remove from the glass rod and they go and deposit on the silk cloth. Okay. So negatively charged particles remove from one object to the other object. After rubbing, what happens? Because of this removal of these negative charges from the glass rod, now the glass rod has more positive particles than that of the negative particles. And when you consider about the silk cloth, it gained more negative charges. Therefore, when you compare the number of positive and negative charges present on the silk cloth, it has more negative charges. So the glass rod is positively charged and the silk cloth is negatively charged. So one object has more positively charged particles, therefore it is charged positively. The other object has more negatively charged particles and therefore it is charged negatively. So I hope this part is very clear now. Okay, so it is clear to you when two objects are rubbed with each other. Rubbed with each other. What happens? One object is positively charged and the other one gets negatively charged, right? One object is positively charged. Positively charged while the other is negatively charged. Remember what happened with the silk cloth and the glass rod? When you rub with each other, the glass rod gets positive charges while the silk cloth gets negative charges. So just imagine, children, if you have two objects, let's say two rods are there. One is positively charged and the other is negatively charged. Let's say if this one has positive charges and the other one has negative charges. What will happen if you keep these two rods close to each other? So you all know that they will attract. They will attract each other. You know that they will come into contact because of the attraction. They will touch each other. Do you know what happens afterwards? When they come into contact, they will exchange charges. Okay, positive and negative charges are exchanged. So then what happens? Let's say that after the first attraction, you take the same rods, you keep them again close to each other. You will not see any attraction like before. So as I told you, because of the first attraction, because they contact or come into contact with each other, they will exchange charges. Okay, they will distribute the charges again equally like before, and therefore they will become neutral. So even if you keep these two rods again close to each other, you will not see anything. Right, children? That is because of the first contact, they exchange charges and they become neutralized again. This is known as neutralization of static electric charges. Okay, children? So accordingly, positively and negatively charged objects contact each other. We will write accordingly, positively and negatively charged objects contact each other. Two objects become, what happens? I told you they exchange their charges and then it becomes neutral. So two objects become neutral. This is known as neutralization of static electric charges. Okay? Therefore, objects do not possess any net charge. Neutral objects, they don't have any net charge. So, a neutralized or neutral object, we can't call it positively charged or negatively charged. Okay? That is because they have equal number of positive and negative charges present on the object. Okay? So, therefore, objects do not possess any net charge. We'll go from the beginning. It's clear to you when two objects are rubbed with each other, one object is positively charged while the other is negatively charged. Accordingly, positively and negatively charged objects contact each other. Two objects become neutral. Therefore, objects do not possess any net charge. So, in order to understand this neutralization of static electric charges, now we are going to do another experiment. So, our activity is testing the neutralization of charged object due to the exchange of static electric charges. Now, you all know that there are two different types of static electric charges, positive and negative charges. So, if one object is positively charged and the other object is negatively charged, what happens when they brought together? They attract. And I explained you due to the first attraction, they will exchange charges and they will neutralize. So we are going to study this theory using this experiment. So what do we have to use here? We need a glass rod, an ebonite rod, and we need a silk cloth and a woolen cloth and a few pieces of thread and two stands. We will write glass rod, ebonite rod, silk cloth, woolen cloth, a few pieces of thread, and two stands. A glass rod, ebonite rod, silk cloth, woolen cloth, a few pieces of thread and two stands. So how do we do this experiment? I will show you. So what is the method? Look at these two diagrams carefully. First of all, you have to charge the glass rod with the silk cloth. You have to rub the glass rod with the silk cloth and charge it. So what is the charge gained by the glass rod due to rubbing with the silk cloth, children? That is positive charges. So here we have to hang the glass rod on the stand. It is positively charged. And then we have to take the ebonite rod and you have to rub it with the woolen cloth. So when woolen cloth is rubbed on the ebonite rod will get negative charges. Understand? So you have to hang that ebonite rod on the stand. So after that you have to keep them close to each other and observe. Okay. So what is this occasion too? You have to repeat the last step. It means you have to keep them again and again close to each other and observe what happens. Okay children, we will write down this one. Step 1. And the glass rod rubbed with the silk cloth and the ebonite rod rubbed with the woolen cloth. On stands. You have to hang them separately. Number 2. Keep the stands with 2 rods close to each other. And observe. And step 3, repeat the above step, which means step 2. Right. Hang the glass rod rubbed with the silk cloth and the ebonite rod rubbed with the woolen cloth on stands. So you have to hang them separately. Keep the stands with 2 rods close to each other and observe. Repeat the above step and you have to observe what happens. Right? Repeat the above step. We will write several times. Several times and observe. Right children? So we will do this activity now. So children, I have the setup like this now. An ebonite rod is hanging and a pen tube is also here. And I can show you when I try to keep this close to each other, what happens? There's no repulsion, no attraction. Now I am going to charge this ebonite rod with the piece of woolen cloth. Nicely charging it. Right. And then I'm going to take the pen tube and charge it with the polythene sheet. Right. Observe what happens. So you all can see they attract. Look at the way they attract. You can see. So why does this happen children? When I rub this ebonite rod with the piece of woolen cloth, it gets one type of charges. Right? And when I rub this pen tube with this polythene sheet, it gets opposite charges. So then you all know that unlike charges, they attract. Right? Opposite charges, they attract. That is why when I hold them together, they attract. I will try to do the same now. You all can see there's no attraction, no repulsion. or very slight attraction is there, but they do not attract towards each other anymore like before. What is the reason, children? Now you all know that during the attraction, first attraction, they contact with each other. During the time they contact, what happens? They exchange these positive and negative charges. Okay, so I already explained you that when you consider a certain object, if a certain object has equal number of positive and negative charges, they are known as neutralized. They are neutral objects. Okay, so earlier when I charged this ebonite rod with this woolen cloth, it got one type of charges, and this pen tube got a different type of, opposite type of charges. Okay, but during the first attraction, when they contact with each other, they again exchange these charges, and the number of positive and negative charges in this ebonite rod becomes equal. In the same way, the number of positive and negative charges present in this pen tube also become equal. So in this case, both the objects become neutralized. Okay, because of exchange of charges, both the objects become neutralized. This is known as neutralization of static electric charges. So what happens, children? During the observation, you observe that the two rods are attracted in the first instance, and later it did not attract to each other, right? So you all know that instead of this glass rod, I use the pen tube, but the same observation can be taken using the glass rod as well. Okay, so what happened? I used the pen tube and the ebonite rod, and I charged them separately and kept them together. Then what happened, children? They attracted. So when I repeated the same step, I mean step 2, when I kept them together close to each other again and again, what could you observe? Did you see any attraction? You did not see any attraction. Okay, we will write down that one. Observations. The first instance, when the two rods were kept close, they attracted to each other. Okay. And what happens when we repeated the same step? It did not show any attraction or repulsion. When they were kept close repeatedly, they did not show any attraction like before. Okay, in the first instance, when the two rods were kept close, they attracted to each other. Okay, when they were kept close repeatedly, they did not show any attraction like before. What happens here, children? I already explained you. This happens because of the neutralization of static electric charges. You all know that during the first attraction, what happens to these rods? They exchange the charges present on them, positive and negative charges, and they become neutralized. Okay, so because of the neutralization of these static electric charges, these objects do not show any net charge after the first attraction. That is why in the second instance, even though we keep them close to each other, they do not show any attraction. Okay, so what is the conclusion? Static electric charges are neutralized because of the first attraction. Okay, we will write that. The rods are neutralized. The rods are neutralized due to exchange. Due to exchange of charges during the first attraction. The rods are neutralized due to exchange of charges during the first attraction. This is known as neutralization of static electric charges. We have this assignment here. Briefly explain how charges are transferred when a piece of woolen cloth is rubbed against an ebonite rod. Now, as a fact, we all know that when an ebonite rod is rubbed with a piece of wool, what will happen, children? The ebonite rod will get negatively charged. That is a fact. So, we will see what happens here. What will happen before rubbing? Before rubbing. Let's consider this is the piece of wool and the ebonite rod. What can you tell about the number of positive and negative charges present on the ebonite rod and the woolen cloth? They are same. They are equally distributed. Positive and negative charges on each object are equally distributed. Therefore, no any net charge. We can't tell that this one is positively charged or negatively charged, and even the rod is positively charged or negatively charged. Okay, so before rubbing, what happens? Charges are evenly distributed. Evenly distributed. Therefore, no any net charge. Okay, while rubbing, what happens? While rubbing, now as a fact, we learned that, I mentioned you before as well, as a fact we learned that when an ebonite rod is rubbed with a woolen cloth, the ebonite rod gets negatively charged. So you all know that while rubbing, one object removes negative charges and those negative charges will deposit on the other object. Right? So the object with more negative charges is known as the negatively charged object, and the object that removes negative charges is known as the positively charged object. So as the ebonite rod has more negative charges, it means those negative charges are removed by the piece of woolen cloth. Okay, so negative charges are removed from the piece of woolen cloth. We will draw that. This is the woolen cloth and the ebonite rod. Ebonite rod, woolen cloth. Okay, children. So what happens? During rubbing, negative charges move from the woolen cloth to the ebonite rod. Negative charges. Understand? Therefore, after rubbing, what happens, children? Now, more positive charges present on the woolen cloth. That is because it removed the present amount of negative charges. Therefore, it has less number of negative charges than that of the positive charges. What happened to the ebonite rod? It gained more negative charges. Therefore, when you compare the positive and negative charges present on the ebonite rod, it gets negatively charged because it has more negative charges. Okay, the woolen cloth has more positive charges. Therefore, it is known as the positively charged object. Understand? So, briefly explain how charges are transferred when a piece of woolen cloth is rubbed against an ebonite rod. We will write down when ebonite rod and woolen cloth are rubbed with each other, negatively charged particles. Negatively charged particles. What is the name? Electrons. Electrons get removed from the woolen cloth. Therefore, after rubbing, ebonite rod is negatively charged. Negatively charged as it has more negative charges. Woolen cloth has more positive charges. And it is positively charged. Okay, children. So, briefly explain how charges are transferred when a piece of woolen cloth is rubbed against an ebonite rod. What happens? When ebonite rod and woolen cloth are rubbed with each other, negatively charged particles or electrons get removed from the woolen cloth. Therefore, after rubbing, ebonite rod is negatively charged as it has more negative charges. Woolen cloth has more positive charges and it is positively charged.